Assignment 4, adding polynomials. Welcome back, guys. So, for today, there's a couple things I want you guys to know. First off, when adding polynomials, make sure they have the same base and exponents. I'll give you examples of that shortly. Next off, you're only going to add the coefficients, not the exponents, but coefficients. So let's begin with a couple of examples. Say we have 4x to the third plus 2x to the third. What you notice is they have the same base, same exponents. That means we're going to add. But remember, what I said is only the coefficients. So 4 plus 2 will equal 6. So my final answer will be 6x to the power of 3, or 6x cubed. Now, let's do more examples. Let's say we have x to the power of 4 plus x to the power of 4. This one, notice there's no coefficient that's written, but you always know when there's no leading coefficient, always think of 1. So 1 plus 1 will give me 2. They have the same base and exponent, so 2x to the power of 4. Those are the answers for the beginning. Now let's actually focus on problems you will face on today's assignment. So let me go ahead and erase, and let's begin. Example problem number 1. Say we have 5p to the power of 2 minus 3 plus 2p raised to the power of 2 minus 3p cubed. Now, when approaching these problems, always start off by choosing the problem that has the biggest exponent. This has an exponent of 2. This one doesn't have an exponent. This one has to the power of 2, power of 3. Now, from looking at all this, the one that has power to the 3 is the biggest. I'm going to begin. So I'm going to write negative 3p cubed. And if you notice, that's the only one. So I'm done on that part. Now, let's go to the next one. From 3, I'm going to go down to 2. There's 2 of them. 5p squared, so 5p squared plus 2p squared. So I'm done using this one. I'll use this one and this one. All I have left is negative 3. So let's do all our math. Let's simplify. At the top, there's nothing to add. So that immediately goes to my answer, which is negative 3p cubed. At the bottom, you do have something you can simplify. 5 plus 2 is 7. So plus 7p squared. At the bottom, there's nothing. So I'm just going to write minus 3. And this is the answer for example problem number 1. Negative 3p cubed plus 7p squared minus 3. Let's go ahead and jump into example problem number 2. So, an example problem number 2. Say we have a cubed, or a to the power of 3, minus 2a squared plus 3a squared minus 4a cubed. So once again, begin with the problem that has the highest exponent. I noticed 2 of them, a to the power of 3, negative 4a to the power of 3. So it's going to be a cubed plus negative 4a to the power of 3. We're going to simplify that shortly, so I'm done using this, and I'm done using this one. All I have left are my power of 2's, right? My squares. So negative 2a squared plus 3a squared. Let's simplify. So at the top, a to the power of 3 plus negative 4a to the power of 3. There's no coefficient here, so we'll always assume it's 1. So 1 plus negative 4, you can think of negative 4 plus 1. You owe me $4, you give me 1, that means you still owe me 3. So negative 3a to the power of 3. Bottom one, negative 2 plus 3 is just the same thing as saying 3 minus 2, which is 1. So you can write it as 1a squared or just a squared. Either one, you're correct. Let's combine our answer. So it's going to be negative 3a cubed plus a squared. Answer to problem number 2. Let's go ahead and jump into example problem number 3. So, example problem number 3. Say we have 4 plus 2n to the power 3 plus 5n to the power 3 plus 2. So let's begin by adding the ones that are the same. Highest exponent. 3 and 3. There's 2 of them. So 2n to the power 3 plus 5n to the power 3. If we add 2 plus 5, that is 7. So 7n to the power 3. We're done with this. Done with this. And if we notice, none of those have exponents, so they're just regular integers, right? So 4 plus 2 gives me 6. We combine our answer. 7n to the power 3. The 6 is positive, so plus 6. Complete. Now let's jump into example problem number 4. Number 4 is a very interesting one that you're going to see shortly. Example problem number 4. On example problem number 4, we're going to have x to the power of 5 plus 3x to the power of 4 plus 2x squared plus x. So let's begin. Highest exponent, x to the power of 5. Is that the only one? Yes, it is. So I'm just going to write x to the power of 5. And now let's go to the next highest exponent, 4. So all I have, that's my only one. So 3x to the power of 4. And then we're done with this one. Next off, do I have anything to the power of 3? No, I don't. So the next big one is 2x to the power of 2, or 2x squared. So 2x squared, that's my only one. All I have left is just x. Notice there's nothing to simplify, so I combine them. Always start off by the biggest exponent. So x to the power of 5 plus 3x to the power of 4 plus 2x squared plus x. And that finishes problem number 4. Example problem number 4. Let's wrap it off with example problem number 5. And that will complete today's lesson. So, example problem number 5. Here we go. On example problem number 5, say we have, oops, let me put this example problem number 5. Oops, that looks bad. Let me go ahead and erase that. Say we have 10v cubed plus 6 plus negative 4v cubed plus 4. So let's begin. Highest exponent, cubes, right? There's 2 of them. So 10v cubed plus negative 4v cubed. So in this case, this means 10 plus negative 4, or 10 minus 4, which will give us 6v cubed. And then last off, 6 plus 4. We add that, that is 10. Then let's combine both our answers. 6v cubed plus 10. And you are complete. So with that being said, guys, finish up the 2 problems for week number 2 and have a good rest of the day. Thank you.